Hi, so my name's Ariana Loriano, and I want to talk today about the case connections for Unit 2. I chose case study number 4 and case study number 3, but I want to go ahead and start by talking about case study number 4. So, from the given case study, we're able to see that the female baby is experiencing hypoglycemia, which is low blood sugar, high blood lactate, an enlarged liver, and high blood glucose levels after breastfeeding. We know that breast milk is made up of lactose, which is a disaccharide made up of both lactate and glucose, as well as, and we also know that in the case study, it states that we have an increase in blood lactate once epinephrine is administered. So, first, I want to talk about choice A, which is hereditary intolerance. And this intolerance is a deficiency in aldolase B. And from this unit's reading and lecture notes, we were able to learn that aldolase B is needed in order to break down fructose 1 phosphate into both dihydroxyacetone phosphate and glyceraldehyde. And those two will then be able to enter into the glycolytic pathway as glyceraldehyde 3 phosphate. So, a deficiency in aldolase B enzyme is going to essentially cause an increase in fructose 1 phosphate, and some symptoms that are going to correlate with the hereditary intolerance is irritation after eating fructose, abdominal pain, which both are not seen in this case study, but hypoglycemia is one of the symptoms and it is seen in the baby. But as I go down the other options, you will find that I chose a different answer that gave more symptoms that correlated with the case study. So for option B, we have galactosemia, and that is a disorder that affects the way our body processes galactose, and galactose is found in lactose. And as we all know, lactose is pretty much in all of our dairy products, as well as baby formula. And some symptoms that go with galactosemia that are not seen in the baby in this specific case study is jaundice, vomiting, irritability, and nausea. The third option, option C, is glycogen storage disease. And I chose this as my answer. And this glycogen storage disease is a deficiency that changes the way our body uses and stores glycogen. And as we know, glycogen is a form of sugar or glucose. And this disorder is caused by enzyme deficiencies. And when an enzyme is missing or we have a deficiency, we're going to have an increase in glycogen because our bodies are not able to break down that glycogen in order to give us that free glucose to enter into the bloodstream. And we should know by now that glucose is our form of energy. And since we're not able to be breaking down this glycogen and use it for glucose, hence that's why the baby in this case study isn't able to maintain glucose levels. Some symptoms that are associated with glycogen storage disease and are actually seen in the baby, we're going to have hypoglycemia, which is low blood sugar, hepatomegaly, which is an enlarged liver and a swollen belly. And lastly, option D is a glucose 6-phosphate dehydrogenase deficiency. And this causes our red blood cells to break down. And this specific deficiency usually affects males, not females. And you could also see it or hear it be called G6PD deficiency. And the symptoms that are correlated with this deficiency are fever, jaundice, shortness of breath, and fatigue. Again, these aren't seen in the baby, so that is why I specifically think that glycogen storage disease is the best answer for case study number 4. Next, I want to go ahead and talk about case study number 3. And case study number 3 essentially says that a 5-year-old boy is showing drowsiness, severe thirst, and frequent urination. Upon checking the boy's insulin levels with the data that was provided, I suspect him to have diabetes mellitus type 1. And diabetes mellitus type 1 is actually insulin dependent. The boy's insulin levels before and 1 hour after a glucose loading test were considered to be low. A glucose loading test is used to test for diabetes. For a glucose tolerance test, also known as a glucose loading test, kind of the steps so we can kind of be on the same page with it, is that the patient is going to be asked to drink a fluid that contains normally about 75 grams of glucose, and then the patient's blood will then be drawn out every 30 minutes or 60 minutes after administration. So with this boy, his glucose loading test said that he had a 0.8 insulin level before the test compared to the normal range of 6, and after the glucose loading test, the boy then had a level of 5 compared to the normal range of 40, so still very low. The second part for this case study question, it says, what would you predict the patient's fasted blood glucose levels to be given his current condition? So above normal range, within the normal range, or below the normal range. So as we know, insulin is a hormone that allows our body to use glucose in order to maintain glucose levels. Having low levels of insulin, as in the case of this boy, is going to cause the glucose to not be used, which then leads to an increased thirst. Being more thirsty causes the boy to drink more water, and this increase of water intake is what then will cause that frequent urination. The increased levels of glucose not being used would then put the boy's fasting glucose levels at above average. So I went ahead and Googled insulin levels ranges, and for it to be considered a normal range, the blood sugar level, specifically the fasting blood sugar level, has to be less than 100 milligrams per deciliter. For it to be pre-diabetic, the sugar level is going to be between 100 to 125 milligrams per deciliter. And to be considered diabetic, the sugar level will then be 126 milligrams per deciliter or higher on 2 separate tests. So in order for it to be considered diabetic, you would have to be at a very high level for both an oral glucose tolerance test as well as the IV glucose tolerance test, which is using a needle. And the last part of the case study question for number 3 says list 2 regulatory enzymes that are likely to be active in this individual's current condition. The regulatory enzymes I suspect to be active in this boy's situation are going to be all of the irreversible steps of glycolysis. And as we know, the irreversible steps of glycolysis is going to be phosphofructokinase, hexokinase, and pyruvate kinase. So we know that hexokinase is used to give us kind of the phosphorylation between glucose and glucose 6-phosphate, and pyruvate kinase does that conversion between the phosphoenolpyruvate and then to give us pyruvate at the end. And then we know that phosphofructokinase also gives us our irreversible steps in glycolysis. So this is my summarization for the Unit 2 case connections, and I hope you enjoyed my explanation.